trig equations. Let's go back to some algebra equations quickly. So for this first problem, we would add 5 to both sides of the equation. So we'd have 6x squared equals 18. Then we would divide both sides by 6. X squared equals 3. Then we take the square root of both sides and we have plus or minus square root 3. So we'd have two solutions, positive root 3 and negative root 3. For this quadratic, we want to get all terms on one side. So if we subtract 20 from both sides, we'd have 3x squared plus 7x minus 20 equals 0. There's no GCF. You're looking for combos that multiply to negative 20 times 3, so negative 60, that add to b, or 7. Once you find that combo, you can replace the middle term and group. And once we do that, factor by grouping, we'll get quantity x plus 4 times 3x minus 5 is equal to 0. Then if you set your factors to 0, your answers would be negative 4 and 5/3. So solving quadratics by factoring. Same thing over here. There's no GCF. We're looking for combo that multiplies to negative 2 and adds to negative 3. For this one, let's see, if we look at it, is there a combo? So 1 and 2, negative 1 times 2 is negative 2. 1 times negative 2 is negative 2. Those are the only combos that multiply to negative 2, and neither adds to negative 3. So when that happens, when you can't factor, you need to use the quadratic formula. So A is 2, B is negative 3, C is negative 1, and we would say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And once you simplify, you should get 3 plus or minus square root 17 all over 4. And let's move on. Now, when we're working with trig equations, it's the same concept, right? We're going to use the unit circle to figure this out. So we first want to isolate cos x. You can think of this as 2x equals negative 1, right? You divide by 2, you isolate x, you would have negative 1/2. However, we're isolating cos x. So it's 2 times cos x, so we would divide by 2, and we would get cos x equals negative 1/2. Now what we're going to ask ourselves is, if we spin around the unit circle, at what angles will we have ratio negative 1/2? Well, let's think for a second. If we know all students take calc, we know that we have a negative cos value, not in the first quadrant. We would have it in the second and in the third quadrant. In the first and fourth, cos is positive, right? So let's think in the first quadrant, where will we have a cos value of 1/2? So we know that cos value of 1/2 is at 60 degrees. So then we'll do reflection. So we know this is 30. This little sliver is 30. We know this is 60, and this is 30, and that's 60. So right here and right here, we will have cos values of negative 1/2. So we know this spot is 90 plus 30, so it's 120 degrees, which we could multiply by pi over 180 to get radians, and we would get 2 pi over 3 radians. And down here, we know we'd have 180 minus that 60 degree sliver. So we have 240 degrees, which is the same as 4 pi over 3 radians. Notice there are multiple values, right? Multiple places that you can have a ratio of negative 1/2. Number 5, we're going to isolate sine squared x. So think of this as 4x squared equals 1. So we're first going to divide both sides by 4. We have sine squared x equals 1/4. And then we're going to take the square root of both sides, plus or minus. So we'll have sine x equals plus or minus square root of 1 over square root of 4, which is plus or minus square root of 1 is 1 over square root of 4 is 2. So we're looking to see where sine is positive 1/2 and where is sine going to be negative 1/2, because it said plus or minus. If we have all students take calc and we're dealing with positive and negative values, we know that we're going to have answers in all 4 quadrants because we're dealing with positive and negative 1/2. So let's look in first quadrant. Sine is positive 1/2 at 30 degrees. So we know it's positive here. All students, we also know sine is going to be positive in the second quadrant. So over here, we would have a value right there at 90 plus 60, so at 150 degrees. So we know sine's positive at 30 degrees and 150 degrees, which you could convert to radians. So pi over 6, 5 pi over 6. Now, if you're getting the answers for where sine's negative 1/2, if it's all students take calc, we know we're going to have negative 1/2 in quadrant 3 and 4. So if you look down here, if we added that 30 here, then we know that little sliver's 30. So we know that 180 plus our 30 degree sliver will get us 210 degrees, which is the same as 7 pi over 6. And if we do a reflection right here, we know 60, this is 60, so we'd have 270 plus 60, which would get us 330 degrees, which is 11 pi over 6 in radians. So that problem actually had four different solutions. Let's continue on. In most applications, the range of values or outputs will fall within 1 revolution. So normally the solutions or angle measures will fall from 0 to 2 pi, or we say 0 to 360 when we're talking about 1 revolution. Notice that if we're revolving 1 time, we say let's start at 0, right? That's why there's a bracket including 0. But as we loop around to look for values, we then say once we land at 2 pi or 360, we're not going to include that value. That's why we have parentheses. So you wouldn't say at 0 and at 360 because you're including that spot twice. So 1 revolution, you'd only say 0, and everything from 0 until you hit 360 as you spin around wherever you get solutions. So they tell us the interval to look on for answers, 0 to 2 pi or 0 to 360. So this next one that we're looking at, it says, let's find all of the answers between 0 and 2 pi, or 0 and 360 degrees, right? I see that this is a quadratic, so I'm going to get all terms on one side. So I have 2 cos squared x plus cos x minus 1 equals 0. I look at this and I notice that it's a quadratic, and I can either try factoring or using the quadratic formula. This problem is factorable. There's a combo that multiplies to -2 that adds to +1. We know that it's 2 and -1. So then when we go to factor this, we have x plus 1 times 2x minus 1. And if we put cos back in there, we know cos x plus 1 equals 0. We're going to solve now. And 2 cos x minus 1 equals 0. So we're trying to look, cos x equals -1. If we add 1 and divide by 2, we get cos x +1/2. So we're first going to spin around the circle starting at 0 and ask ourselves, where will cos be -1? Well, we know that this is 1, 0. We know this is 0, 1. We know this is -1, 0. And we know this is 0, -1. Cos is on the left side, so it's not -1 here, not here. Here we have a cos value of -1 at 180 degrees, or at pi. And then when it says cos x equals 1/2, we know all students take calc. We know we're going to have cos positive value here in first quadrant, not here, not here, and in the fourth quadrant. So in the first quadrant, we have a cos value of 1/2 at 60 degrees, or pi/3. And we also, all students, let's see, all students take calc. So down here, we have 360 minus 60, so 300 degrees is where we'll have that other value. So 360 and 180.